Now the next inventory model that we have to study is the EOQ model with price break. Now EOQ model means the same EOQ, the Wilson model that we studied, the very first model that we studied, with price break. Now what is a price break? How does it affect the overall calculation, and how do we actually solve a question with price break? That we are going to study first, and then after that we are going to solve this previous year question to enhance our understanding of this topic. Now whenever you go out in the market to buy something, especially when you go out to buy something in bulk, in large quantities, you negotiate with the shopkeeper, right? You tell him that I am buying 10 pieces of this product, and I am buying 50 pieces of this product, so please bring your prices per product low. If he was selling it for rupees 100, you will ask him to give it for rupees 70, for rupees 80, right? True or not? And this happens everywhere, right? It is not true only for your transaction, it is true for even the transactions that happens between one business and the other business. A supplier supplies any raw material to different industries, right, which they uses to make any useful component, any useful product. They also maintain an inventory. We have already discussed that in detail. We are actually discussing that only, that every industry has to procure some raw material, purchase some raw material from some supplier in order to continue their production, right? Now since they are also buying the product in bulk, they are not making one product or 2 or 10 products, they are making thousands of products on the daily basis. So the consumption of raw material is huge. It's very huge as compared to what we buy normally by going to the shop. So if we are asking for a discount just to buy 10-50 pieces, don't you think that these businesses will also be negotiating with the supplier when they are having consumption in so many large numbers? They do this negotiate the price with the suppliers, and even suppliers beforehand give them different price slabs, different discount slabs, that if you order more, if you buy more from me, I will give you lesser price per product, or I will give you more discount. And that is what was given to you in the question. In the previous year question that I just showed a picture of, in that question same table was written, and in a similar way you will be given some table, some price slab to you in the question. And what is it exactly telling you? In a way it is telling you that if you order more, how much per piece or per kg is going to cost you will decrease. You can see here, when you are ordering less than 750 kg, from 1 to 749 kg from the supplier, per kg he is charging you 70. But when you order more than 749, from 750 to 1499, you are getting this per kg price even lesser. If you order more than 1500, and if you order more than 1499, means 1500 and above, you are getting even the lesser price of 60 per kg. So what trend you can see? That when quantity is increasing, the quantity may be in number, the quantity may be in kg, depending upon the question, it does not matter. But you will see the trend that when quantity is increasing, the unit price will decrease. That is very logical. When you order more, you expect to pay less price for per piece, per product, per kg, whatever it is. Correct? So in this way, you will be having different price slabs. That is what is written here, or price break. You are having a price break here, right? When quantities are changing, right? So you have 3 different price breaks, you can say, or 3 different price slabs, you can say. You have just 2 breaks here. We will talk about that later. So these are the price slab model or price break model of EOQ. Now in this case, what you are expected to do? You are expected to find out that how many kgs you should order. Okay, and generally this will be asked you in the question, that how many kgs you should order to have the minimum total price, or what will be the total minimum price. These things will be generally asked to you in the question. Now this calculation is going to be little bit different than the calculation that we have done in the earlier models. What we have done in the earlier models? In the earlier models, we calculated the ordering cost, we calculated the carrying cost, and if there was shortage cost and other costs, we calculated that. And those costs were added to get the total variable cost or total inventory cost, right? I told you that the purchase cost component was constant and the variable part was ordering cost, carrying cost, which was basically a function of Q, of how many quantities you are ordering. That is why it was called as total variable cost or total inventory cost. But in this case, even purchase cost is a variable cost. Purchase cost is not a fixed cost. How? In the earlier cases, if annual demand was D and price per unit was C, so D multiplied by C was the total purchase cost, right? But here if you look, depending upon how much you are ordering in per order, your cost is different. How much you have to pay is different. If you have 3000 units or 3000 kg demand in 1 year, okay, in the same example, and you decided that you will make 2 orders of 1500 kg each. So for each order you have to pay 60 rupees 60 per piece, correct? And upon adding, that will give you a price, correct? Means per kg you have to pay 60, per piece I am saying, okay. But suppose the same demand of 3000 you decided to fulfill by making 4 orders of 750 each. 750, 750, 750, 750, correct? How much you have to pay for each of them? 65 per kg. Here also you are ordering same 3000 quantities. Overall if you compare in the whole year, here you bought 300 kgs, here also you bought 300 kgs. But in this case you paid rupees 60 per kg. Here you paid rupees 65 per kg. So obviously total cost of purchase will be more in this case than this one. That is why in this case, when you have been given different price breaks or price slabs, the purchase cost will also be a variable cost. So the total variable cost in this case will also add the purchase cost. Interesting? Now, let's plot this on a graph. Let's see how the variation of total variable cost, you can say, or let's include PC in total cost only. Let's say total cost is a variable. Total cost is equal to purchase cost plus total inventory cost. These things I have already covered in the earlier models, right? So let's plot total cost on the graph, okay, which is total inventory cost plus purchase cost, which is a variable in this case. So this is how the total inventory cost varied, and total cost was just above the total inventory cost by purchase cost. This is telling you quantity, right? And this is telling you cost, right? So I told you that total cost is, since it is just more than TIC, total inventory cost by the purchase cost, so variation of TC will be same or similar as TIC, but it will be little bit higher than that. So if we want to plot TC in this case, and we want to plot TC because TC includes purchase cost, ordering cost and carrying cost, all of them are variable. So we want to plot TC in this case and not TIC. This is how this model is different than the previous ones. In the previous models, we were focused on TIC only because purchase cost was constant, but here purchase cost is also a variable. So we will be considering purchase, ordering, carrying, all the 3 costs in order to find out the answer, okay? And we are going to start by plotting the graph as I told. So we will be plotting the curve of total cost as I have shown here. Now, how many curves will be there? Will a single curve be sufficient for all 3 cases, or we will be having 3 different curves? Now, since each of them have different purchase cost, you may think that, sir, all 3 curves will be similar, just one curve will be above of the other like this. Since purchase cost will be higher in this case than this, so we will be having 3 curves like this. This is what you may think, that this will be, let's write this as A, as B and C. So this curve will be for A, this will be for B, this will be for C. You may think like that, but this is incorrect. This is not how the variation is going to be. Now, why is that? Look, although the question gave you that you have different purchase cost, but in a way, carrying cost or holding cost will also be different for all of them, for each of them. I have explained this concept to you, that how carrying cost is a function of unit price, right? If you buy any random stone, this is the same example that I gave you earlier, that if you buy any random stone which are to be used in any small household work or for any random work, you will just buy it and you will store it in the open. But if you buy precious stones, diamonds, then will you just buy the diamonds and lay them out in the open in your inventory? No. You will be spending a lot of money to secure that. You will be installing security system. You will be making sure that even not a single piece of diamond is broken, is cracked, is stolen. Nothing happens to that, right? You will do everything you can to make sure that it stays as it is, right? In quantity as well as in quality. But you won't spend that much money, how much you spend on diamonds, on storing any random stone. Construction industry also uses stones. They don't spend so much money on just storing stones, right? They just store it in the open, no security, nothing. That is logical also. If you are spending more on buying something, you will spend more on maintaining it also, because that is costly, right? So purchase cost is going to affect the carrying cost. The carrying cost is a function of purchase cost. So if purchase cost is decreasing from A to C, the carrying cost will also decrease in the same fashion, in the same manner from A to C. So all these three are not only having different purchase costs, they are also having different carrying cost. So it means that their graph will not look just like this. It's not the case that only purchase cost is different, so we'll make one curve above the other. But the whole curve will be different altogether, because carrying cost is also changing, right? So we'll be having three different curves. Let me draw them for the three different price slabs that we have been given. Let me draw them. So I have drawn three curves A, B, C here, which represents three price slabs A, B and C. The lowest point in each of those curves represent the EOQ for that price slab, right? A is the price slab, so for that price slab this is the EOQ, for B this is EOQ, for C this is EOQ. Each of them have different EOQs. And if you notice, the EOQ for C is more than EOQ for B, EOQ for B is more than EOQ for A, right? So in a way, what the graph is representing, that if you order more, the EOQ for that range will be more. C has the maximum order quantity, so EOQ for C is maximum, right? This is just graphical observation, and you can also get this proven from the expression. D and CO are constant. Annual demand and ordering cost are not changing, but carrying cost is a function of unit cost, like this. So if quantity which is order increases, if this Q increases, then unit price is decreasing. If unit price decreases, carrying cost decreases. If carrying cost decreases, EOQ increases. So what you can conclude, that when Q is increased, this Q star or EOQ also increases. And that is what is shown here, that for each of these price slabs, highest EOQ is coming. This is the highest value of EOQ for C, is coming for that price slab where you have ordered maximum, right? Now one more thing you can observe here. Now if you compare the total cost at EOQ star, whenever we put star, it means we are talking about the EOQ, the optimal value. So the optimal total cost for A, total cost at EOQ for B, total cost at EOQ for C. Observe them. There is a pattern, right? Total cost is decreasing. Total cost at EOQ is decreasing in this order. When you move to higher quantity slab or lower unit price slab, as you move ahead, the total cost at EOQ is decreasing. Now, why am I telling all these things? These things are very details of this graph. And trust me, they are not taught anywhere else. They are not explained anywhere else. But there is a very basic reason why I am doing it. I am doing it so that you understand this graph, how this graph is laid out for all of these price slabs. The two things I told you, that if you move from A to C, the Q star increases and TC star decreases. What it means? That the curve of B will be lower and on the right side of curve of A. Why lower? Because total cost is less. Why on the right side? Because Q star increases. Similarly, the curve for C will be lower and on the right side of curve of B. Now you got an idea of how these curves are going to be laying out, how the layout of this curve is going to be for all of these price slabs. And this will extremely help you in understanding the process. I can directly tell you the process. Okay, these all things are not even needed. Even without even knowing these things, you will get full marks. But you won't understand the process. I don't want to directly tell you the process that follow this and you will get the answer. I want you to understand that how the graph is laying out and how you can actually use the process to find out the answer. So let me clean up this graph and then I will start telling you the process. Okay. Now, given the three graphs which are representing three slabs, if I ask you that what is the best number of quantities that I should order, then what you will say? This one, right? Because it has the least total cost of all. This is the lowest point on this axis, on total cost axis. So you will say that let's order these many quantities, right? But this is not the question. The question is not so simple. Why? Because it has given you some slabs of quantity. You do not have this whole curve with you in the question. You only have this curve for a set of quantity, for a range of quantity. The curve B is only for a quantity of 750 to 1499. Means maybe from here to only here. Maybe this is representing 750 and maybe this is going to be 1499. Okay, random values. Then you can see that only from here to here you have this curve applicable. For quantity less than 750 or more than 1499, you do not have this curve because you do not have this price slab. This quantity, this unit price you are not getting outside of this range. So this curve is not valid outside of this particular range. In a similar way, other curves also are not valid throughout. Only in certain region. This is the region, let's say, where curve B is valid. Maybe this is the region where curve C is valid and not after that. Maybe this is the region where A is valid and not beyond that. So you will be able to see that for a certain quantity, A curve is applicable. As you can see here, for a certain quantity A is applicable. Then for the next quantity, for the next range of quantity B is applicable. Then for the next range of quantity C is applicable. So you can see a sudden jump from curve A to curve B, or you can say sudden break from curve A to curve B. That is why the name is price break, right? So there is a sudden break in the price. This is the price or cost from A to B at this point, right? And this curve, if I draw from a solid line so that you can clearly differentiate it, this is the curve which we have for the given question. Okay, this is going on ahead. And the dotted one is not the curve available to us. Now you have to tell the total minimum cost in this. Now you have to compare that which point is representing in this solid line. Okay, in this solid line, which point is representing the least total cost, that you have to see. That is going to be the answer. You can see here that in this particular graph, this is the lowest point. I'm not saying that in this question also this will be applicable, because I have randomly made the graph. As you have seen, I have not drawn it to the scale, but if it was drawn to scale, this was the minimum total cost and it was representing which quantity? When C was starting, the point where the C slab was starting, it was starting at 1500. So 1500 quantities would have been that number for which the total cost will be minimum. Okay, but obviously for this question it will be different. I'm just giving you an example of it. Now there is something to understand here, that it is not necessary that EOQ for any given price slab is going to fall in this solid line. EOQ for A is definitely lying in the solid line, but you can see that EOQ for B is not in the given quantity range. Similarly, EOQ for C is not given in the total quantity range. The EOQ for C maybe will be less than, as given in the graph, the EOQ quantity for C will be less than 1500. From here C is starting. So EOQ, if that is not lying in that range, that EOQ is called as infeasible EOQ. Infeasible EOQ or unconstrained EOQ. Now, what you need to do in this question, let's understand the process. The process is that you need to calculate the EOQ for the given price slab. Okay, you can start from anywhere. It is best to start from the least unit price slab. I will tell you why later on. So let's say you started from this price slab, everything will be given to in the question, annual demand, ordering cost, everything will be given. So you can calculate Q star like this. If Q star or EOQ is lying in this range from 1500 or more, means you have a feasible EOQ, then it's fine. But if you have infeasible or unconstrained EOQ, if EOQ is not lying in that range, then you have to cancel that slab. That slab will not be selected. In this fashion, you have to move from the lowest unit price slab to the higher one. Okay. Now, suppose, as I have assumed that this question is represented by this graph, although I cannot say yes or I cannot say no because in front of you I have not solved the question. We will separately solve the question to see. But let's assume that this graph is representing this particular question. So in this case, you can see that for slab B also, this EOQ will not be falling in the feasible region, right? So B will also be cancelled. But for A, the EOQ is lying in the feasible region, right? So this slab will be selected. Means whatever is the EOQ for this slab, that will be selected as a valid point to check the total cost. So we have selected till now one point, which is this one, the EOQ for the first one, where we are going to check the total cost, whether it is coming out to be minimum or not. Obviously, in this case, it is not coming out to be minimum. You need to compare this EOQ with some other points. But what should be those other points? That you need to understand now. You need to compare any feasible EOQ point. Feasible EOQ point like this one with higher price break points. What are the price break points here? This is the point, right, where price is breaking. This is the point where price is breaking. These are infeasible ones, so I am removing them. So how many points you are comparing? You are comparing feasible EOQ, then you are comparing this point, then you are comparing this point. You will find out the total cost at these 3 points and least of them will be selected. Least of them is obviously giving you that quantity for which total cost is least. This is how the question is solved. Now what you will find in different sources that they will directly tell you, most of them will directly tell you that calculate the total cost at any feasible EOQ and at price break. Least cost will give you the desired answer. But why it happens, that you can understand from the graph. The EOQs are going like this, right? For any given curve A, curve B and curve C, if you have selected EOQ for any curve, let's say the EOQ for curve B was feasible. Let's assume that EOQ for B was feasible. Then will you consider the EOQ for slab A? Listen to the question again. If EOQ for B is feasible, so that is obviously going to come here. You will obviously compare its total cost. But will you consider the EOQ for price slab A or any further higher price slab? No, you won't. Why? Because you can clearly see that EOQ point for A, if you compare EOQ point for A, B and C, the point EOQ for A will be having a higher cost than B. The EOQ for B is having a higher cost than C. That is why understanding the curve is important. You know that the price at EOQ for A will be more than B. So if you have two feasible EOQs, suppose in the question you have A also is having feasible EOQ, B is also having feasible EOQ. Which EOQ will you select? You will select the EOQ for B, not for A. You will select the EOQ for the price slab B and not for any price slab above of B. Why? Because it is going to have a higher total cost. Total cost for A at EOQ is higher than the total cost at B for EOQ, right? That is why understanding the curve is important. And what is the process? The process for solving this question is that you start from this particular slab, okay, from the lowest unit price slab, find out whether it is having feasible EOQ or infeasible EOQ. Repeat this for B, for A, or maybe you are having 4 slabs, 5 slabs in the equation. Start from the bottom and move up. As soon as you found a feasible EOQ range, forgot about the previous ones. That's why I told you start from the bottom, because even if you have any feasible EOQ in the higher price range, in the higher price slab, that will be having higher total cost, right? When you are moving from C to A, as you are comparing different EOQs, the price total cost as at EOQ is increasing. If the total cost as at EOQ is high, obviously the total cost at any other point on that curve will be high, because EOQ represents the lowest cost. True? That is why I told you move from the bottom. Only you have to pick, if you have more than one feasible EOQs, you have to only pick that price slab and that EOQ which comes first when you move from the bottom. When you are moving from the bottom, the first feasible EOQ you have to select. Any feasible EOQ, if exists above that, when you are moving from down, don't consider that. It will be having a total cost higher than that. Don't waste your time doing that calculation. Okay, so which points you need to compare? Any EOQ point, any feasible EOQ point that you found out when you started from the bottom, and other price break points that you found out. So in this particular question, if this graph is correctly representing this case, then you have 3 points to compare. This EOQ for A, then this price break point for B, B is having infeasible EOQ, then this price break point for C, C is having infeasible EOQ. What is the best way possible? Let's solve this question and see how this question will be solved. What will be the best way in which you can quickly get the answer? Suppose the EOQ came in the first slab itself. You are finding out EOQ for 1500 and above, and suppose if EOQ came in this region itself, means C has a feasible EOQ. Answer will be C itself. You don't need to calculate for other price breaks. That is why understanding this is important. You will save, if the calculations are longer, you will save at least 1 minute in gate, 1 to 1.5 minutes in gate, if you understood this question correctly, if you understood this concept correctly, and you can very well understand the value of 1 or 1.5 minutes in those 3 hours, right? So start from the bottom. As soon as you found out feasible EOQ, stop there. Don't look up. Don't look for the upper slabs. And for that EOQ, you calculate the total price. And for all the price breaks below that EOQ, which you have covered so far, for that also you calculate the total price. For this one, for this one, for this one. Compare them. Least of them will be your answer. That's it. Now I have said enough. I have explained enough for this model. Let's start solving this question. And if you have any confusion here and there, that will be totally cleared when we attempt this question. It's a previous year question. Let's try that. Now let's discuss the initial previous year question that I showed you. Ideally, I want you to pause the video and try that question, because we have thoroughly discussed the concepts of this model and you should be able to solve that question. Anyway, go through this question again here, and meanwhile I am continuing the discussion. So this was the table given to us in the question. This is the annual demand as given to us in the question. Ordering cost is rupees 500 per order and carrying cost is 20% of purchase cost per kg. All these things are given you for 1 year. Okay. So 20% of purchase cost per kg means if this is the purchase cost, so rupees 60 is the purchase cost per kg. So in carrying or in holding 1 kg for 1 year, you have to spend 20% of this amount, means 20% of 60 is rupees 12. Okay. So in this way, it will be 20% of each of them. And it's asking you that how much quantity it should ideally order. It's not necessarily Q star, because it's not necessary that EOQ will be the answer. How much quantity you should order in kgs so that the total cost is minimized, right? Now look, I have already told you how to solve that question. Always start from the bottommost slab. We will call that to be the first slab, but it is actually the bottommost slab of the highest quantity slab. Okay, let's name it highest quantity slab. So this is the highest quantity slab. You have to start from there. So for this slab, we are calculating EOQ, and we will see whether the EOQ of this slab is feasible or it is infeasible, right? If EOQ for this slab is feasible, we got our answer there itself. The answer will be the EOQ for that slab. I have already explained you how, right? But in case it's an infeasible EOQ, then we will keep moving ahead until we find the feasible EOQ. So for this slab, the EOQ calculation is done here. Root 2D CO by CC. D is 25,000. Carrying cost is 500. These two are same. Carrying cost is 20% of the purchase cost for that slab, which is 60. So put 60 here. Upon solving, you will get this. These many kgs are the EOQ for that slab. Now look at this slab. Slab is saying 1500 or more. You will get this price only if you order 1500 kg or more. But when you calculate the EOQ, it is coming 1443 point something, which is definitely not lying in this range. So this EOQ is infeasible. It's not in the given range of quantity, right? So this slab has been discarded. Now let's move to the upper slab of 750 to 1499. For that, the purchase cost is 65. So in the EOQ formula, plug in the value of carrying cost, which is 20% of 65. Upon solving, you will get 1386.75 kg. Now look, in this range, the EOQ is lying. The range is from 750 to 1499. It is 1386 which is lying in the range. So we got the feasible EOQ. Now you don't have to calculate the EOQ for the upper range. For the first range, you don't have to do that. Okay. This is the benefit of knowing the concept. Otherwise, you will continue the calculation. You will waste your time. Okay. Now, we stopped there. These are the two EOQ values. This one got rejected because it is not in the range. This is infeasible EOQ. This is the feasible EOQ. Now, for this EOQ, you have to calculate the price, and for other breakpoints which are higher than that EOQ, you need to calculate that point. Calculate the value of total cost. How many price slabs do you have above that EOQ? Only one here, right? EOQ is lying in this range, and above that range, you have only one price break at 1500. So what you need to do? You need to find out the total cost at the EOQ of the second slab and at the break point at 1500 for the third slab, right? I have done the calculation here for the total cost at the EOQ. That's why I'm putting up star here for the second slab. So since EOQ gives the minimum cost, so minimum variable cost of the carrying cost and ordering cost is given by this expression plus the purchase cost. That will give you the minimum cost for EOQ, which is in the second slab. If you put the values of D, CO, CC is again 25% of 65. For annual demand of 25,000, it's costing you 65. You put all the values, you solve it, you will get this much amount you have to spend per year. It's the annual cost, total annual cost. TC is showing total annual cost if you order by the EOQ of the second slab. It may be minimum, it may not be minimum. How will you know? You will have to compare the feasible EOQ with the higher break points. With the higher break points, there is only one, that is 1500. So at 1500, you do the calculation. Now, many students will do one mistake here. They will put the value in this expression itself to find out the total cost in this slab. But don't do this mistake. This expression is specifically valid for EOQ, right? This expression we already use. In this case, we have added the purchase cost as well, as I told you that we consider that also in the price break model. So we have added that. But overall, this expression can be applied only at EOQ. Don't randomly apply it for any slab. Okay. In this range from 1500 and above, we don't want to calculate the price at EOQ, because the EOQ for that range is infeasible. Okay, so if you plug in the value of this range of, if you put 60 here, 20% of 60 and 60 multiplied by 25,000, it will give you the total annual cost at the EOQ at these many quantities, which is not selected. So at what quantity you need to find out the total cost? At 1500 itself, because 1500 and above consider so many points, the least of that will be 1500 at the price break. So how do you calculate the total cost at the price break? Total cost is equal to the direct cost, which is 60 per kg multiplied by annual demand of 25,000 kg, plus ordering cost 25,000 total demand. For one order you are ordering 1500, the quantity at the break point multiplied by the ordering cost, plus you have to add the carrying cost. The average inventory multiplied by 20% of charge per kg for 1 year. Right? These expressions we have already discussed thoroughly before this model. So we have just finding out the value from the very basic expression of total annual cost. Doing this will give you, so this is the total cost coming when you are ordering 1500 kgs per order. This cost is clearly less than the previous one when we were considering the EOQ of the second slab. Hence, the answer for this question is 1500 kg, because out of the 2 points, this is having the least cost. Now let me just quickly show you how the graph, the actual graph of this problem will look like. The earlier graph that I showed was hypothetical one, right? That graph was hypothetical. So let me give you an idea of how the graph will look like. So curve for this case may look something like this. This is for the first slab. I have shown totally this one with the dotted one because we don't care about it. We know that its price will be, the EOQ of that will be having a higher total cost than the EOQ of the second one. So we are totally ignoring this one. This is for this slab and this curve here is for this slab. You can see that EOQ of this one is feasible for the second slab, but EOQ for the third slab, or which we wrote here as the first slab, let's call this first and second. So EOQ for the first slab was infeasible, it was out of the range, right? EOQ for the second slab was feasible, but the EOQ of second slab was giving you a total cost which was higher than the cost calculated at 1500. This is Q is equal to 1500, and at that point you got this cost which is lesser than the cost at the EOQ of the earlier slab. So this is how the curve will look for the first and second slab. So you've got a clear idea of how to solve these questions. You can assume that multiple types of theoretical as well as numerical questions can be framed from this. 2-3 questions have been asked in previous year till 2019, GATE 2019, and I'm sure there are chances of this being asked any year in the coming GATE. Okay.